Okay, we're going to begin here with factoring polynomials. This is just a refresher, but first we always have to look for a greatest common factor. That's what this says right here. For example, if we have something like 4x to the third power plus 2x squared, what you would want to do is look at all the terms and think to yourself, is there anything that I can take out from everything? Look at the 4 and the 2. I can take a 2 out from both of those. That's the greatest common factor of 2 and 4. And then x to the third versus x squared, I can take an x squared out of both of those. I'm then left with a set of parentheses, and I just basically divide both of the terms or all of the terms by the number that's out front here. So 4x to the third divided by 2x squared. 4 divided by 2 is 2. X to the third divided by x squared is just x. And then 2x squared divided by 2x squared, this is just going to end up being plus 1. So first and foremost, always look for the greatest common factor. And then we have several different factoring processes. In Algebra 1, we don't learn all of them, but we do learn what happens when we have two terms here. And this is usually difference of squares. So for this example, we've got x squared minus 64. And when this happens, we have two perfect squares. X squared is a perfect square, 64 is a perfect square. When you have a difference, a subtraction problem of two perfect squares, this factors into x plus and x minus, and then 64 is a perfect square. The square root of 64 is 8, so this factors into x plus 8 times x minus 8. Now, the second one doesn't look like it's a difference of squares problem, and that's because first we would have to find the greatest common factor. So I can look at these two terms, 18m squared n minus 2n to the third. I'm going to take out a 2 from both of these, and I'm also going to take out 1n from both of these. I then would be left with 9m squared minus 1 n to the second power. Now, it still doesn't seem like it is a difference of two perfect squares, but it actually is. Inside the parentheses here, we have a difference of two perfect squares. 9 is a perfect square, so is m squared. 1 is a perfect square, so is n squared. So this would factor completely with the 2n out front, and then I set up two separate sets of parentheses, break up the 9 into 3 and 3, break up the m squared into m and m. One's positive, one's negative. Break up the 1 into 1 and 1, and break up the n squared into n and n. You don't necessarily need the 1's there, but you could have just the 2n times 3m plus n times 3m minus n as an answer. In Algebra 1, we also learned how to factor three-term polynomials, which are called trinomials. And this is really important to remember. When we have a trinomial, like this example right here, x squared minus x minus 42, of course we cannot take a greatest common factor out of that. There's nothing I can take out that is a common number or variable for all three terms here. So this is not the process. The process is find the factors of the last number. So the factors of 42, 1 times 42, 2 times 21, 6 times 7. Find the factors of 42 that multiply to be 42 and at the same time add to be the middle number. So when we're doing this, we also, I forgot 3 times 14, but we are doing two things at once, finding what multiplies to be the negative 42, but adds to be the middle number here, which is negative 1. So in order for this to happen, to multiply to be a negative, one number has to be positive, one has to be negative. So just pick a number that you want to make negative. Negative 1 times 42 is negative 42. That checks out. But negative 1 plus 42 is 41. That's not going to work. We need it to add to be negative 1. So it's not going to be this pair, and it wouldn't be if you flipped it around either, because then you were just going to get negative 41. The pair that it would be 6 and 7, because if I make 6 positive and 7 negative, 6 times negative 7 is the negative 42 that we need, and 6 minus 7 is negative 1. So this factors into x plus 6 times x minus 7. Now on the Keystone, if they give you a question and it's like, what's the factored form of x squared minus x minus 42? And they give you 4 answer choices. And one of the answer choices is x plus 6 times x minus 7. And maybe you have, 3 other options as well. What you would just do if you forget how to factor at that point is use the answer choices to your advantage. If you prefer to multiply and not factor, which those are opposites of each other, then what you could do is take each answer choice and multiply it out. X times x is x squared. X times negative 7 is negative 7x. 6 times x is 6x. 6 times negative 7 is negative 42. Combine like terms, x squared minus x minus 42, you get the original answer, so you would know that answer is B. Now, sometimes the Keystone does not have multiple choice questions. If this question was an open-ended, then you would have to do it the correct way. But sometimes, you will have multiple choice, more times than others, actually. So use the answer choices to your advantage if you can. Now, the second example here is 2w squared plus 20w plus 50. Now this one does have a greatest common factor. We do need to take that out first. We divide each thing by 2 because that's the greatest common factor here. This will turn this into 2 times w squared plus 10w plus 25. Now we look at this number. What multiplies to be 25? 1 times 25 and 5 times 5. That then also adds to be 10. It would be 5 and 5. So we can factor the w squared plus 10w plus 25 further. We still keep the 2 up front, but now we have 2 separate sets of parentheses, and this would be w plus 5 times another w plus 5, and that would be our final answer. In Algebra 1, we don't learn, or you won't have to do on the Keystone, these other processes. So we don't have to worry about this, but we will learn that in Algebra 2. Okay, we're going to skip a little bit. That was just a factoring refresher. And now we're going to move on to dividing a polynomial by a binomial. So this is the last section with the factoring that we need to learn. So what we're going to be doing is using factoring to divide. We're going to see fractions, and in our fractions we're going to have polynomials in the numerator and in the denominator, and what we would need to do is factor both the numerator and denominator, cancel out any common factors, and then the remaining stuff is the answer. For example, x squared plus 7x minus 8 over x minus 1. Let's factor both the numerator and denominator. Now the denominator cannot be factored. X minus 1 is just going to stay x minus 1. But the numerator, x squared plus 7x minus 8, let's factor that. The factors of 8, 1 times 8, 2 times 4. We technically need it to multiply to be a negative 8. So let's realize one of them has to be positive, one has to be negative. So I'm just going to choose negative 1 and positive 8 to start, and negative 2 and positive 4. Well, negative 2 times 4 does equal negative 8, but negative 2 plus 4 gives me positive 2. That's not going to work, and neither will it if we flip around the negative. But actually, negative 1 with a positive 8 will work perfectly. X squared plus 7x minus 8 factors into x minus 1 times x plus 8. So what we now have is a fraction in factored form. When we have a fraction that has polynomials in factored form, what we can do is then cancel out any common factors that are in the numerator and denominator. Now the denominator x minus 1 cannot be factored. If it's helpful, you can put parentheses around it when it can't be factored, just to show that this is the quantity x minus 1. And then anytime you have a fraction, if you have the same exact thing in the numerator and denominator, those things can be canceled. Even if the fraction was like 2 times 3 over 5 times 2. Like this 2 and this 2 can cancel out. Your answer would be 3/5. Similar to that, x minus 1 and x minus 1 can cancel out, and our final answer would just be x plus 8. That's our final simplified answer. So what this section requires us to do is just factor the numerator and denominator, and then cancel out the things that are the same in the numerator and denominator as pairs, and then what we're left with is the answer. So helpful hint, when you're looking at your problems, x squared minus 10x plus 21, they're basically set up so that like you can use the other numerator or denominator part of it as like a helpful hint that that's probably going to be one of your factors. Let me show you. Like x minus 7 is going to be one of the factors of the numerator. What multiplies to be 21, automatically I'm always like 3 times 7. That's my initial thought. And in order for it to multiply to be a positive 21, but at the same time add to be negative 10, both of these would have to be negative. So x squared minus 10x plus 21 factors into x minus 3 times x minus 7. X minus 7 can't be factored. I'm just going to put parentheses around it. What I have here is the same thing in the numerator and denominator. X minus 7 and x minus 7 cancel out. And I kind of thought that would happen because that's the whole point of this, for it to cancel out. So what we're left with is our final answer of x minus 3. So use the other things as a helpful hint, like number 2, m minus 9 is most likely going to be one of the factors of the numerator polynomial. What multiplies to be 45? Lots of things, but let's focus on just like the 9 here, 9 times 5. Well, in order to multiply to be negative 45, one of these would have to be negative, so negative 9 and positive 5. Negative 9 plus 5 is negative 4, which is what we need, so that's exactly it. This factors into m minus 9 times m plus 5. And then our denominator is m minus 9. Put parentheses around it. It can't be factored. Cancel it out. The final answer is m plus 5. Now, each one's going to be slightly different, like number 3. The factored form of y squared minus 25, we have to realize this is a difference of squares problem. This factors into y plus 5 times y minus 5. Now, the denominator is y plus 5. So you can use that to your advantage and realize, like, okay, most likely y plus 5 is going to be one of the factors because the whole point for this is for things to cancel out. But you will have to know how to use factoring with all the different processes to arrive at your final answer, which in this case would be y minus 5. Now, number 4 is interesting. It's actually not going to require us to do what multiplies to be this, adds to be this. It's just going to be a greatest common factor problem. The greatest common factor of 2r squared plus 16r is 2r. And when I divide 2r squared by 2r, I'm left with r. When I divide 16r by 2r, I'm left with 8. So I get 2r times r plus 8 in the numerator. You can always multiply it back through if you need to check to make sure. And the denominator is r plus 8, which is the same thing here, cancels out. We're left with 2r as our final answer. Now, a question like number 5 would not pop up on the Keystone, more like Algebra 2 there, so I'm going to skip that. Number 6, 15v plus 35. We could factor out a 5 from the numerator, leaving us with 3v plus 7. And my denominator is 3v plus 7. Look at that. The whole thing cancels and cancels. The answer to this question would just be 5. Now, number 7 we will do. Number 7, technically the numerator, 16k squared minus 1, seems like it cannot be factored because a lot of times we always think that the greatest common factor is the only way, but it can be. This is a difference of 2 perfect squares. 16 is a perfect square, so is k squared. Minus is a difference, and then 1 is a perfect square. 4k plus 1 in the denominator cannot be factored. Let's break up the 16k squared into 4k times 4k. 1's positive, 1's negative, and break up the 1 into 1 times 1. Once we have that, we can see 4k plus 1 and 4k plus 1 cancel out. What we have left is 4k minus 1. That's our final answer. Now, sometimes the questions are going to come a little bit different. They're going to look maybe something like this. And when it is written out horizontally like that, my suggestion would be to just rewrite it as a fraction. So I'm just going to show you one of these. Just rewrite it like this to start, and then do the same thing. What multiplies to be negative 33 adds to be 11. Well, that's going to be, or sorry, adds to be 8, and that's going to be c plus 11 times c minus 3. And then I have a c minus 3 in the denominator. Boom, boom, gone. Final answer would be just c plus 11. So if that ends up happening, just write it out as a fraction, and then you should be good. So that should be enough practice. What we are going to do now is complete the homework. We're not going to do all of these because some of these are not going to be for Algebra 1, specifically for the keystones. The questions I'd like you to complete are numbers 1, 2, 3, 4, 5, 6, and 7. That should be enough practice. So numbers 1 through 7 for practice as your homework.